Before first exercise, there will be sums, no, sir. I mean, example sums, no, sir. We can complete it today, and we will complete today's homework too, sir.
First, complete the rest of questions from the exercise.
So only one exercise, sir. Second exercise is optional.
Second exercise we can complete in the next class, not an issue.
Yes, sir.
Sir, it's an optional question, sir.
Which one is optional question?
So second exercise, sir.
Even the 3 to 4 questions are there, so we can complete it.
Okay.
Yes, sir.
Right, let us see this one. Complete the following statements. Probability of an event E plus probability of the event not E. What's the result? P of
So
E
one.
plus
One, sir.
P of not E is 1. So this is 1. The probability of an event that cannot happen is. What is it, mother?
Zero.
Yes.
Sir, 0 and it is impossible.
So we discussed in the last class, P of E is 0. Probability of an event is 0. Such an event is called there.
Sir, impossible event, sir.
Impossible. The probability of an event that is certain to happen is.
Sir,
one.
Sir, and certain event.
Called
Sir, certain
Sure event, sir.
or sure event
Sure
or
event.
certain event. Next, the sum of the probabilities of all the elementary events of an experiment is.
Sir, 1.
Sir, one.
Yes.
1.
So P of E1 plus P of E2 plus and so on, P of En is always 1.
1, sir.
So the result is 1. The probability of an event is greater than or equal to dash and less than or
0.
equal to dash.
0 and 1, sir.
In the previous class we discussed about the probability of an event is always from 0 to 1 only.
1, sir.
So it is greater than or equal to 0 and less than or equal to 1. Isn't it?
Yes, sir.
That's it. So which of the following experiments have equally likely outcomes? Explain. A driver attempts to start a car.
Sir, not equally likely, sir.
Why?
Sir, because when
Car
there is a
starts or
problem
does
in his,
tell me.
ma'am, when there is a problem in his car, so that only it cannot start, sir.
Yes, here we need some information whether the car is in good condition or not.
Yes, sir. Sir, if it is mentioned means we can see.
Yes, if the information is given clearly, then we can say that it is equally likely. Not only car, no, even driver also. If he is not in the good position also, he could not start.
Yes, sir.
Then it says that it could not start only. We cannot balance it as equally likely outcomes. So the next one is a player attempts to shoot a ball. She or he
So not
shoots
equally
or
likely, sir.
misses the shot. Here also we need some information regarding this,
Yes.
whether the player is in good condition or not. Right?
Sir, and the position of the player is more important, sir,
Yes.
to put score.
Next. So this is not equally likely event. This is also not likely event. While writing the notes, you write the statement clearly and write it is not likely equally outcomes. Then the third one is a trial is made to answer a true or false question. The answer is right or wrong.
Sir, equally likely, sir.
Equally likely outcomes.
Because true or
So
false
1 by 2,
question,
1 by
we
2.
have either true or false.
Yes.
So the question gets true or false. Whether you say the answer, if I ask a question, if you say the answer, there are only 2 options. It may be true or false. So it is equally likely event.
So probability will be 1/2 and 1/2.
1/2 and 1/2. And the next one is a baby is born.
Sir, equally.
It is a boy or girl.
Sir, equally.
So equally
Oh,
likely
either the
outcome.
baby is
1/2,
boy or
1/2.
girl.
Sir, either it may be a boy or it may be a
Maybe
girl.
a boy or girl.
That's it, ma'am.
Yes, sir.
So it is equally likely outcomes. If it is other than that, the information should be given. Till that, generally we will consider it as either boy or girl. So that we can consider this as equally likely outcomes only. Right?
Yes, sir.
Next. So we'll go to the next question. So let us see this one. So here Y is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game. Why we are tossing a coin, no?
Sir, because it is a random experiment, sir. We cannot predict before itself, sir.
Yes, it is a random experiment. Result
And also there
gives,
may be a chances of occurring tail or head, sir.
yes, that's it.
Only
That is
two
the
options,
main.
sir.
If you toss a coin, there is a chance to get either tail or head. So both also equally likely events only. The probability of getting tail and head, isn't it?
Yes,
So
sir.
that we'll choose to toss a coin to who have to start ball first, get the ball first.
Yes, sure.
So the result is could not predict in advance, and it has equally likely outcomes. So that we'll choose tossing a coin who has to get the ball first. Next. So the next one is a direct question. Which of the following cannot be the probability of an event?
So minus
option
1,
B, sir.
1.5.
1.5.
As we know that the probability lies between
0 to 1, sir.
probability of an
0 to
event
1.
lies between 0 to 1. From 0 to 1. So it is negative is given, it is less than 0. So that it cannot be the probability of an event. And the next one is so probability of an event is given. What is the probability of not A?
So we have to
Zero-
minus
we
it
know
with
that
1, sir.
Probability of an
0
event
0.9.
plus probability of,
Not getting any image.
yes, not an event is always 1.
1.
So probability of an event is given. We should substitute it 0.05 plus probability of an event, not event, equal to 1. So probability of not event is 1 minus
So
0.05.
0.5.
So what is the result?
So 0.95.
Therefore, probability of not an event is 0.95. 95. That's it. Next. So let us go to the next one. So here it is. A bag contains lemon flower candies. So bag contains lemon flower candies. Malini takes out one candy without looking into the bag. What is the probability that she takes out? The first one is an orange flavored candy.
So 0, sir.
Sir, it is impossible.
So,
sir.
Completely
the
it's
bag
filled with
contains
lemon candy.
only
Lemon candies.
lemon
It
candy.
contains only lemon candies.
So there are no orange candies. So lemon candies, few are there, and orange candies are number of
0.
orange candies are 0 only.
Yes.
So orange candies are 0. So that the first result is the first one answer is probability of getting orange flavored candies. Is number of favorable outcomes. You write the formula for all the questions. Number of favorable outcomes divided by number of total possible outcomes. Harini, can you see this one?
Yes, sir. I can see it, sir.
All right. So this is
Clear now,
0
sir.
by total number of possible outcomes. So how many are there? We do not know. So let us consider first. Let number of lemon
Sorry,
flavored candies be x. Then you can write it as x. 0 by x is 0. So the next one also same. So the next one is probability of getting a lemon flavored.
Lemon flavored candies.
Sir,
Lemon
x
flavored
by
candy.
x1, sir.
So yes, ma. Lemon flavored candies. Again, write the same formula. Number of favorable outcomes by number of total possible outcomes. So number of favorable outcomes. All lemon flavored candies can be taken. So x by total number of possibilities are the bag contains only lemon flavored candies. So total also x. X by x is 1. That's it.
Sir,
Tell me.
sir, how sir x by x is equal to 1?
X 1 times x will get cancelled. You can divide it.
Yes, sir.
X 1s are x. So these two gets cancelled. The resultant value is 1. Clear?
Yes, sir.
Right. So go to the next one. So here it is given. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability that the 2 students have same birthday? So how do we find it, ma? One is
Sir,
not
We have to
having
minus
birthday.
it with
minus
yes.
0.99.
So one is happening event, another one is not happening event.
Not a
So that you should mention it and you can complete it. So first write probability of 2 students are not having same birthday. Are not having same birthday. Suppose consider it as a P of not E is 0.992. Then the other one is probability of 2 students
Having the same.
are having same birthday, right? Are having same birthday. This is considered as P of E. This is what we have to find. Since P of E plus P of E bar or not E equal to 1. So we can get this result is P of E plus P of E bar is 0.992 equal to 1. That implies P of E equal to 1 minus 0.992. Therefore, P of E is, what's the result?
0.00.
Yes, 0.008.
008, sir.
So this is 1. So the other one is 0.992, right? So after a decimal, take 3 zeros. Then it is, take from here 10, then it is 8, here 9, 9. So that this is 0, 0. Here already we have taken. So this is also 0. So the result is 0.008.
Yes,
That's
sir.
it. Next. So let us go to the next one. So the next one is a bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red and not red? If you find red,
3
it's
by
not
8.
red. That's it. You write it. Number of red balls 3 and number of black balls 5. Right? After complete that, then we can write the first one is probability of getting red ball. Total balls are 3 red
8,
balls
sir.
and 5 black
sir.
balls. Total 8. So red balls only we need. Red balls are 3 only. So 3 by 8. And the second one is, you should write the formula also. Number of available outcomes by number of total possible outcomes. Then write 3 by 8. Right? Then go to the next one. Not red ball. Not red ball, there are two ways. One is probability of getting not red ball.
So that is
Directly you
probability
find
of
out
getting
this is
black
there.
balls.
So not red ball in the sense black balls only.
Black one.
So 5 by 8. Or we know that
Sir,
P
1
of E
minus
is,
3 by 8.
so take it as P of E is happened event. and P of E bar is not happened event is 1. So P of E in the sense probability of red balls 3 by 8 plus probability of not red balls equal to 1. Do you understand it? So probability
Yes,
of
sir.
not red ball is 1 minus 3 by 8. Find the LCM. That is 8 minus 3 by 8. So the result is 5 by 8. So anyone we get the same result. Right?
Yes, sir.
Sir.
That's it. Then we'll go to the next one. So the next one also same model. So here it is given. A box contains 5 red marbles. 5 red marbles and 8 white marbles and 4 green marbles. So first write number of red marbles 5 and number of white marbles 8 and green marbles 4. One marble is taken out of the box at random. What is the probability that the marble taken out will be red? And the next one is white. And the third one is not green. Right? So let us take the first one. You write the statements. The first one is probability of getting red. Total balls, how many are there?
Sir, 17.
17.
Sir,
5 red
17.
balls,
17, sir.
8 white balls, and 4 green balls. Yes, ma'am. So probability of red ball. Red balls are 5 only. 5 by
5 by
remaining.
17.
Total 5 plus 8 plus 4. So the resultant is 5 by
7.
17. And the second question. Probability of white ball. Getting white ball.
So 8 by 17.
Yes, white balls are 8 by 5 plus
5
8
plus 8 plus 4.
So this
17.
is also 8 by 17. The third one is, we need not green balls. How do we get not green balls?
So by adding the red
Sir,
marble
add
and
the
white
red
marble.
ball and white
Ah, yes.
13,
The
sir,
first method is
13.
you can add these two and you can subtract.
Sir, because they are the sure events.
And one more method is there, not green. When it is not green, we know that probability of green ball plus probability of not green
White ball and
is 1. Isn't it?
yes.
So first let us finish it. The next one is what you said, we will discuss the same. So probability of green ball. Green balls are 4 only. Sorry, green marbles. No? So this is 4 by 17 plus probability of not green ball. Green marble is 1. So we get this result is probability of not green marble is 1 minus 4 by 17. If you find the LCM, 17 minus 4 by 17. So what you get the result is 13 by 17. Do you understand it?
Yes, sir.
So or else what you said, we'll discuss the same. We'll go to the alternate method. For the third one only. So probability of not green we need. Probability of not green in the sense, probability of red and white only.
Red
Some of
and
the
white,
probabilities of red and white. Right?
Yes, sir.
Probability of red plus probability of white. So probability of red 5 by 17 plus probability of white 8 by 17. So total it is 13 by 17. So you got anyone is same result. So you can use any one method. I hope so it's clear, right?
yes, sir.
So if anybody has a doubt, let me know. We'll discuss it.
No, sir.
Sir. No, sir.
Okay, fine.